Good afternoon. Thank you very much to the AHF for this great opportunity to present 3 new technologies that will drive surgical precision and efficiency in total hip replacements going forward. My name is Eske Peterson. I'm co-founder and CEO of Medichanical Engineering out of Denmark. And the reason we started this company is because current intraoperative technology leaves a huge unmet need to also address the biomechanics side of the equation. So numerous publications and sources here, the American Joint Registry documents that not only implant positioning and orientation, but also cup fixation and sizing are important factors and important for reasons for revisions in total hip replacements. So that's why my co-founder, Dr. Nielsen, out of Aalborg University Hospital, invented the dynamic force trialing principle, which we have materialized here in our X-pander device, which consists of a single-use sizing head with a porous coating, resembling the porous coating of your cup that bites into your acetabular wall. So mounted on a handle, easily like this, and when you dial it, it expands. So once you're done with your reaming, insert the expander into the acetabulum, dial it up, and once you feel that you have this primary stability that you want of your cup, you have validated in just a matter of seconds that you have done your acetabular preparation well, while you still have a chance to fix it if something is wrong. More than that, you can read off a scale the exact acetabular shell size needed for this particular bone quality to create that primary stability that you want. So this product is commercially available and is used by Dr. Kameth at Cleveland Clinic, who's here and happy to take questions with me after my presentation. This product has been used in more than 3,000 procedures to date. It's been documented in peer-reviewed published literature that it increases intraoperative precision in more than 33% of cases. And keep in mind that this is just a manual, analog surgical device. Well, we all know that the future of orthopedics is data-driven and it's technology-assisted. So one of the reasons for me to be here is because with the right strategic partner, we can harness the full potential of integrating biomechanic measurements with robot technology to take the next quantum leap ahead, to make sure that robots not only make sure that you stay within certain positioning and orientation safe zones, but also on a patient-specific level, that you make sure to stay within bone quality adjusted force versus fixation safe zones. So that's why we patented this concept. Now, the other reason I'm here is to talk to you about our brand new expandable single-use reamer concept. Because over the past couple of years, surgeons, hospitals, distributors, vendors, the industry, everybody basically has been asking us, can you make this expander into an expandable reamer? And the reason they're asking is because it seems like everybody wants to get rid of these reusable reamer sets that are out there because they get worn and inaccurate, they cost a ton to reprocess, and they need to be replaced and maintained. So that's why we're seeing currently a growing appetite and request in the market for single-use solutions. And compared to these alternatives up here, our technology excels by allowing for conventional stepwise reaming of multiple sizes with just one single-use reamer head per case. So we've been able to do this simply by mating our patented and proven expander design with that of a conventional reamer shell. And it looks like this, and as with the expander, it clicks easily onto the reamer handle like this. And as with conventional stepwise reaming, you start with the smallest size, let's say a size 50 millimeters. You ream and you medialize your acetabulum to where you want to go. Now, instead of having to change to a different size reamer shell, you simply just dial up the handle 1 millimeter, and now it's 51 millimeters. So you ream up to 51, you go further to 52, and finally to 53, whereafter you're left with a perfect hemispherical bone bed ready to impact your cup, and you've just used one single-use reamer during the entire case. So far, we have proven that this concept works in sawbone specimens by slicing up a conventional reamer shell and gluing it onto the 3D printed model. We've shown that we're able to ream up sawbones acetably to +3 millimeters and create that nice hemispherical shape that we want to. So the next step from here is for us to produce a more durable prototype suitable for cadaver protocols to put in the hands of surgeons. So from a business case perspective, we're looking at a +80% gross margin with an ASP of $175 per single-use unit. So that means if one of the major OEMs were to roll this out on a large scale and penetrate 10% of the market, they would be looking to cash in more than 35 million of annual gross profit. And then when you factor in the savings that comes from phasing out the reusable reamer sets, then they're looking at a total annual net impact on the P&L of around 50 million USDs. So I have to admit, it's not only when I'm at the AHF meeting that I'm surrounded by much greater minds than my own. Back home, I'm also fortunate enough to be part of a very skilled and experienced team, including former President EMEA of Biomet. We're currently funded by Danish business angels, and that's also why I'm here, looking for partners and investors to bring the expandable reamer to market. We've got an accelerated timeline for this, and we expect that if we hit full throttle by now, then sometime in the latter half of 2027, we'll be able to go full-scale launch with this. For that, we're looking to raise $2 to $2.5 million US, and in return for that, we're prepared to offer an attractive equity deal. So, in summary, I'm very excited to identify our coming strategic partners with whom we can harness the full potential of this three-arm technology portfolio that we have, starting with the expandable reamer. I think that was my 8 minutes of fame. Thank you very much for your attention, and now I'm happy to take questions with Dr. Kamath. Thank you.
Thank you. Great presentation. My question is more on the business model. How do you think, is this solving a big enough unmet need that there'll be enough people willing to pay for this? And do you think this will, especially the trialer, will they use it in every case, or is this only specific cases where they see?
What we're seeing is that the surgeons regard it the highest for revision procedures where you got bone defects and compromised bone stock. I think this should be included as in the set from the big vendors so that surgeons can open one when they need one. Remember, they come pre-sterilized, so when they don't need it, they don't need to open one. But I think what I said is that the next step for us is to roll out this new expandable reamer. That's really where I see the value driver in the near future for us.
Do you see enough people paying for this, like in your research? Because today, these things are available for free for hospitals, right? From manufacturers.
You're talking about the reamers now. I know that nobody has yet penetrated 10% of the market with this, as I said, but it's clear to everybody that more and more single-use reamers are emerging in the market. And the fact that we are being asked over and over again the same question every time we're presenting the expandable trial, I think that indicates that the market is maturing and ready to go that way.
Thank you. That's one more question on the business model as well, actually stems from the value proposition first. But so there's how much time, cost are we adding to the procedure by doing this? Like you said, the surgeries are moving more towards being data-driven, more technology. As we build robotic solutions, we want to make it a single step to the acetabulum, right? So when you introduce a step like this, are you adding cost? Are you taking out inventory? Going back to JR's question, when we're monetizing this, what are we taking out of the system, and what are we adding in? So have you done any cost-benefit analysis on what this costs a hospital or a vendor to deploy?
So you're asking what kind of time we add to the procedure?
That's one criteria, but there's also, are there less screws being put in? Are there fewer trays? Are there any other drivers of value when you use this?
I mean, for the expander trial, you can remove the entire tray of trials, which I know is not even in there in a lot of the cases, but in those where it is, it can be removed. In the other cases, as I said, they will only use one when they need one. So when it's a challenging case and they would for some reason be struggling with fitting the cup, they can now do it in just a matter of seconds and make sure that they know immediately what size cup they need. So it will be saving time in this situation. With the expandable reamer, we're not adding any time at all. We're actually saving some because they don't need to change from one reamer to another. They just dial it up to the next size and move along. So that would be more time efficient. But that's not really what I think is the main value driver here. It's more on the single use and the cost saving side, that they only need to use one and still can apply the same reaming technique as they're used to.
So have you got like a dollar number around what you think in an average care setting, wherever this is being used right now, how much dollars does it save? How much money does it save in terms of getting rid of inventory or trays or anything else when you give this single-use reamer?
You can see in various different publications that sterilizing a tray in a hospital costs anywhere between 80 to 200 bucks. So that can be taken out of the equation, and that's a direct saving. And then we know for the OEMs that there is a cost associated with maintaining and replacing, etc., the reamers that can be saved too. So that alone leaves a benchmark of something like, is it 150 to 230 or so bucks per case that can be saved. But what I'm more interested in, we can see now hospitals starting to pay for single-use reamers, and they pay from 110 upwards per case or per reamer, and in most cases they need to use more than one reamer, right? So that's why we think that staying at around 175 USDs for one expandable reamer would be a good price point.
So as you can tell by the questions, right, we're all, for those engineers up here like myself, we've been using these dopey cheese grater reamers for 50 years.
Yes.
There's a cheese grater. We have not evolved from a cheese grater. We have a robot, but we still have a cheese grater cutting acetabular bone, right? Think about that. And the reason we've not evolved from that, as you could tell from this cost perspective, is because they're stamped, they're sharp.
Yep.
We can hold really tight tolerances to it. Mm-hmm. And our inventory carrying cost of deployment of sets in places is not all that high. So I think in some of your analysis, you're mixing up the customer all into one pile, right? One customer is the orthopedic companies if you want us to distribute it, and that's our cost of inventory overall, right? Remember, even though we may load up an ASC with 4 or 5 of each, there's only 1 or 2 or 3 that are being used. So you have the placement inventory cost, but the replenishment inventory cost is not a huge burden to us. So from that. Then there's the hospital perspective of saving on cleaning, saving on sterilization, reuse, and all of that kind of things. But so I would go back to the cost side where we've all tried to scale up nuanced reamers. Making a couple is okay. Scaling up and holding the tolerances so we're not creating a new clinical issue, and the tolerances that we currently have on spherical reamers are pretty darn good. We got a lot of teeth, and we don't have to worry about it expanding and still holding to a tolerance where if you're starting at a 52, what's your tolerance at a 56 when it expanded? So I think the tolerance and the effective cost to hold that tolerance may drive your COGS up a little bit more. But I will go back to some of the clinical issues we've seen over these 5 decades of use with these reamers. And that's when you have an interrupted cut like you do have on that rim. If you're Charlie here and you're toggling a reamer and you catch that little corner when you're starting and stopping and you just grab the rim of that acetabulum, you can easily, when you restart, pull off a chunk of bone. So design nuances to assure that you're not creating a new clinical issue by having it resolved after so I say that as a loving engineer trying to resolve things, but we're at a really good place right now with reamers. We hate them, but we're at a really good place, and it's got to be an improvement.
Yeah, thank you. Thank you.